storage. Kubernetes is OpenShift is the same. There is no much difference. So my work is mainly on Kubernetes for new features and for OpenShift on the maintenance side. And I'm going to talk about what happened, why it doesn't work, what's new in Kubernetes, what we have done in last year. And it has been a busy year. Kubernetes is released 4 times a year in pretty stable cadence. OpenShift is not as stable as we would like. For example, 3.7 was released 2 months later than we would expect, and we will skip OpenShift 3.8 at all, and we will release 3.9 later this year. But the features you get them slightly later, but you get them tested, fixed, and enterprise ready. The first release in March was Kubernetes 1.6, and we promoted storage classes to stable. So if we use storage classes that are stable, we are not going to change them. We have external dynamic provisioning. We have new volume plugins. I think these 2 new volume plugins are the last that were accepted, and we don't accept new volume plugins anymore. So if you have any new fancy storage backend, then sorry, Kubernetes won't support them directly, but we will support them via different interfaces. Some internal projected volume plugin that allows you to mount secrets and config maps and other stuff into one volume was introduced, and we introduced mount options. Later that year, we introduced local storage. That means you can use your local devices on your machine, on your servers, as a storage device. This is useful for bare metal deployments, or if you run in clouds. Both Amazon and GC allows you to spin up a machine that has also a local storage available, and this is super fast, and it's quite cheap storage. So Scale.io and Provox were not the last. Storage OS is the last. So we have new Storage OS is new startup founded by guys from Google. They're trying to do something better, and we introduced some new metrics for management. In September, we added resize options for volumes. So if you run your application with some volumes and they are getting too small, you can resize them now. We added snapshots. You can take snapshots of your volumes. This is external feature. We don't have internal API for that yet. We will see how it goes. You can limit the local ephemeral storage by quota now. You can register your flex volume plugins dynamically if you want. We have mount options stabilized, more metrics, and we added more mount propagation. And in December, we added block volumes. We added scheduler changes to accommodate storage living in different zones or data centers or on different machines. So the workload that needs the storage runs close to the storage and is scheduled closer to the storage. We added resize. We fixed resize, and now it can resize also the file system on volumes. A major improvement is that flex volume is stable. It has been beta for a very, very long time. As long as I remember, it has been always beta, and we didn't know what to do with that. So now it's stable. It's not going away. The API is stable. On the other hand, probably we won't introduce new features there. And the major feature there is CSI, that means Container Storage Interface Volume Plugin. As I have said, we don't accept new volume plugins anymore, but this is the one that is going to shadow everything. container storage interface is a gRPC-based interface between container orchestrator like Kubernetes, like Docker Swarm, like Mesos. It's not Kubernetes specific. And between storage backends like Ceph, Gluster, EMC, NetApp, and these kind of storage backends. And we probably will move all internal storage volume plugins into CSI. So everything we have in tree, like Amazon, Gluster, Ceph, Hostpath, everything, we will move outside of Kubernetes because we have too many volume plugins, we have to maintain them, and it's increasingly hard. So we will put them outside, and somebody else will maintain them, or they will die. For example, we have volume plugin for, there was a new cool startup, Flocker. We have volume plugin for them, but they went out of the business, so we have volume plugin for them, we maintain it, we keep adding new features to them, but we won't do that anymore. Good news for you is that we will keep the API stable, so if you run your application, you have your PVs, they are Amazon PVs, they will keep to be Amazon PVs, but internally in Kubernetes, we will translate it to CSI probably. So, that's a year in Kubernetes. It has been a very busy year, and I have a couple of demos for the bigger features, but are you interested in something concrete? Anything caught your eye?
What's the difference between local storage and Hostpath?
Good question. I have a talk, 2 slides about local storage. I will go to them later. Any other questions or interests? If there are none, then I will start with local storage. So, local storage. Unlike Hostpath, local storage is for devices. Hostpath will make a directory on the machine, on the host, available to a container, so you can change something on the host if you want, or you can use it as a storage if you want. But local storage will give you whole device. What is it good for? On Hostpath, if you have many applications using Hostpath, then they compete for the I/O operation. So if you have one busy pod that runs a lot of file system operations, it will get slow because other pods compete for the same device. With local storage, you can dedicate the whole device to one volume. You can declare it as one volume and give it to a pod, so no other pod will eat your IOPS on the device. That's the main difference. It's a local storage. That means if your node dies, your data are gone. So you should be prepared to lose some data. Even Amazon doesn't guarantee that the node that you have with a local storage is not decommissioned or breaks or anything. So you can lose your data, but on the other hand, you get full speed of local device. So in Amazon, it's cheaper and it's really fast. It's local SSD. The same on GCE. You can do anything with the devices. If you are Ceph or Gluster developer, you can write a deployment that uses these local devices, puts Gluster or Ceph on top of them, and provides them as a cluster storage and reliable cluster storage to whole Kubernetes cluster. That means if one node dies, that nothing really happens because we have many replicas of the same data. With local storage, I covered all this. All these features are mostly in alpha or in beta, and if you want to play with them, you must explicitly enable them on command line. And the feature you need to enable for local storage is called persistent local volumes. And since the data is on one single node and the workload that uses the data can run only on this single node, we had to extend the scheduler. Now, with old scheduler, we already support running pods on specific nodes. So if you write a pod, you can say that this single pod can run only on this single node because the data for is there. It's easy, but people don't like writing pods. They write stateful sets and deployments and these kind of things. And the way we treat storage now is when somebody creates a PVC, the persistent volume claim request for storage, and we bind it to some PV. Simple. But since the PV is local to one machine, all the pods that use the PVC must run on the single machine. On the other hand, pods have their own scheduling policies. We have taints, tolerations, affinities, anti-affinities, and node selectors, and all this kind of stuff. So the pod, for example, can ask for two CPUs, but the node where the storage is doesn't have two CPUs. It has only one. So we cannot schedule the pod to the storage because it doesn't meet the pod criteria. In order to fix it, we put the binding of storage to the scheduler. So scheduler, if schedules a pod, it looks not only at the pod, but it looks also at the PVC. And the PVC is unbound at that time. So the scheduler looks both at the pod requirements and storage requirements at the same time and puts both the pod and the storage on the same node or in the same availability zone on Amazon or the same data center or whatever topology you have. It's not limited to local storage, but the local storage is the driver and it's our guinea pig for that. That means we change the way how storage works. As I have said, if you create a PVC, it is immediately bound to a PV and nobody cares. But now you have an option as an application developer to delay the binding to PVE and wait for the first pod that uses the PVC. So the scheduler can schedule both at the same time. This is opt-in. So if you don't do anything, then all your PVCs get bound to PVs immediately. There is a new field in storage class. So if you set this field in storage class, then any PVC that refers to the storage class is not bound. It waits for the first pod and it's bound during the scheduling. We don't have any dynamic provisioning yet. This will be interesting, and it's limited to local storage during alpha.
So, sorry, does it apply also to EBS volumes? As these are also specific to availability zones of scheduled arbitrary? It
will. In the end, it will support also Amazon availability zones or cloud availability zones. It will support any topology you define if you have data centers across your world and you want to have your storage and the pods in the same data center. It will support any topology you need. It's assumed that the topology of the storage and the nodes is the same. That's one glitch. It's not always It's not always true, but now the assumption is that storage and nodes have the same topology. Otherwise, I don't know how we could do that. So, how to deploy local storage is pretty hard, actually, because Kubernetes refuses new APIs, basically. You need to have really strong reason why new API needs to be in Kubernetes. You have to convince a lot of people and climb many hurdles. And a lot of PCs that were traditionally inside Kubernetes are moving outside. Local storage helper, I would say, is one of them. So inside Kubernetes, we have the volume plugin, we have the scheduler, everything is there. But the thing that takes care about the local devices and provides them as persistent volumes to Kubernetes is outside. So you have to deploy it, you have to create the service account and deployment, and you have to define also what devices do you want to consume also. This is currently a very manual process. We don't support log devices right now. You have to mount the devices actually into some special directory and so on. This will get better, don't worry. Just for alpha and for playing with scheduler and playing with local storage, it's manual. And in the end, well, I have a live demo, which will have, I will try a live demo. So, I have a namespace where all the helper runs. It basically scans one directory and provides all the directories, subdirectories there as local volumes. It's very stupid right now, but it's good for testing. And it has provisioned me a couple of volumes. I have two. If I look at a volume, it's a traditional persistent volume. We have new volume plugin that's called local. It leads here. Nothing special about this, only there is a node affinity annotation. This is a hint for scheduler. If a port references this, if a port references PVC that references this PV, it must be scheduled of the node that matches this node selector. And the node selector says that the host name must be localhost. So anytime scheduler sees a port, the reference is the PVCs, it looks at the PVs. If it sees the annotation, it schedules the pod on this node if it matches the other criteria. For example, you can have a PVC, you can have a pod with two PVCs, and each of the PVC can be on different node. In this case, sorry, it can be scheduled. Or the pod can request, I don't know, too much memory, too many CPUs, whatever. Where am I? So if I create a claim, this is just a simple claim, nothing special about it. I want read-write one storage, I want 1 GB of it, and I want a local storage class. I want a storage class local storage, which is this storage class. It is just a regular storage class, and it has, oops, sorry, that's the wrong storage class, that's the right one. It has volume binding mode, wait for the first customer. What does it mean? I created the PVC, but the PVC is pending, it's waiting for the first customer. Says waiting for first customer to be created before binding. So this PVC is unbound, it waits for the first pot. If I create a pot, and look at the PVC, now it's bound. And the pod is running and everything. It's not running yet, but it will be running hopefully soon. Now I think about it, I hope I have all the images here. Anyway, it would be running. So that's the big change in the scheduler. If you need scheduling of storage and pods at the same time in scheduler, you must enable alpha feature, and you must use a special feed on storage class. All the other PVCs, I don't have Wi-Fi, sorry. All the other PVCs that refers different storage classes work the same, like now they are bound immediately or provisioned immediately. So that's one feature, one quite complicated feature. It's alpha. We are playing with scalar and it's hard. Anything else caught your eyes? If not, I will talk about CSI because it's the future. CSI. Thanks. CSI, Container Storage Interface. It's available in Kubernetes 1.9. It's very, very, very alpha. It's just the first working version. We will fix it. It has many corner cases. Where it doesn't work. It's ugly. It's hard to deploy. Container storage interface started, from my point of view, it started at KubeCon Seattle November 2016. It's ancient. Where we had a 6 storage meeting and we were talking about Flex, how clumsy it is and how to improve it. There was a proposal how to make gRPC interface out of Flexi instead of exec. And somebody thought that everybody else needs the same, not only Kubernetes, so let's make a standard out of it. So I wasn't involved in that, in these talks, but somebody talked to Docker, and to Mesos, and also to the storage backends. We had strong support from Dell EMC and from Diamante, and also some other storage companies. I don't remember right now, sorry. But they came together in one room and they created a gRPC interface between the container orchestrators like Kubernetes and storage backends like, I don't know, Ceph. It's tailored to the use cases we need. So currently, it can only create and delete volume. It can only attach it to a node, and it can mount and unmount it. That's it. You don't have anything else there yet. The CSI standard is 0.1 right now, and Kubernetes is the first proof of concept that it works. New features will come. It's starting to get slightly political. All the storage vendors, they want nice, cool features that nobody else cares about. They want them in. But right now, it's very volume. It should be called container volume interface. Create volume, use the volume. That's it. It's open standard. It lives on GitHub. You can send pull requests. There are weekly meetings. You can join. There is no like entry fee or committee that would approve your pull requests. Just send pull requests. That's it. In Kubernetes, we created a new CSI volume plugin that does provision. Well, it doesn't do provisioning. It does only the attach and mount things and number of external components. And it's very hard. Well, it's not hard to deploy it if you know what you are doing. And we will provide you deployments and templates and everything. But before CSI, everything was nice in Kubernetes. Everything was in Kubernetes. There were 3 daemons running, and if something broke, you knew where to look in these daemons and in their logs. Now, we have external provisioner, we have external attacher, we have CSI register, we have the CSI driver itself as running in a container. And if something breaks, nobody knows what break. Deployment is pretty complicated. On the right side, we have Kubernetes master that runs its own API server and controllers. On the left side, again, it's Kubernetes kubelet. That's the thing that runs on nodes and starts containers. And in between is CSI. To deploy CSI, you must run a CSI driver on every node. We use a daemon set for that. And this CSI driver exposes Unix domain socket on a host. And kubelet, when it wants to mount or unmount something, it calls the Unix domain socket with some gRPC. And we have a helper, we call it registrar, that registers the socket to Kubernetes. And the green part is provided by Kubernetes, by us. We develop that and ship that. The yellow part is up to the storage vendor. We have some mock drivers, we have some simple testing drivers, and companies are starting to write real CSI drivers. So they're jumping pretty early to CSI. So on each node you must run a pod that does the mount thing. And somewhere in the cluster, it doesn't really matter where, we use a stateful set for that. You must run provisioner and attacher. Provisioner, of course, provisions the volumes for you, and attacher does third-party attach and detach. That means if a node goes down and it has attached volume to it, this external attacher can detach the volume. Not all storage backends support that. For example, if you use NFS, there is nothing that would unmount this NFS from that node. It's kind of automatically unmounted. Or if you run iSCSI, again, I don't know too much about iSCSI, but the attach and detach is initiated on the node. So if the node dies, there is nothing that could initiate detach. But in the cloud, if you run in Amazon, you can have third-party attach and detach. So some software somewhere can tell, please attach this volume to that node, and it attaches that. And also the detach works the same. So this stateful set runs attacher, detacher. It runs provisioning, and it talks again to some CSI driver running somewhere in the cluster. I have a demo here. It's not much a demo because it's very simple. I have a... Do I have storage class? I have a storage class. It's just a common storage class that refers to special... Well, it's not a special provisioner. It's just a provisioner that lives outside of Kubernetes. Kubernetes doesn't know anything about this provisioner, and it's task of the external provisioner to provision volume. So if I have a claim, nothing special about this claim. It just refers to storage class and requests 1 megabyte of data. It gets immediate. Oops, it's not immediately bound. Oops, sorry. That's the only demo I don't have recorded. Storage class, the host path not found. I have to create a storage class. It will get bound eventually. So it got bound because I run number of external components in a different namespace that took care about the provisioning. If I create a pod, the pod won't run because I don't have images, but we should see it got mounted. So it got attached and mounted by these external components. So CSI, in short, it's new storage interface. Storage or cluster admin has to deploy a number of components to make it running. On the other hand, user that creates applications, that creates PVCs, doesn't care about anything. It works the same it worked always. We are, as I said, it's alpha, and we are improving it. But if you want to test it, feedback is really welcome because it's a big thing. Any questions?
Is it also topology aware?
Not yet, because CSI itself is not topology aware. The gRPC interface we have to storage backends doesn't say anything about topology. So adding new features to Kubernetes becomes harder because you must fix the CSI first, convince all the storage vendors that this is interesting to fix. They must update all their drivers, and then in Kubernetes we can consume it. So it will slow everything down. I don't know. So right now it's not topology aware, but we want it to be topology aware, of course. And as I said, eventually we have the idea that we would put all the internal volume plugins in Kubernetes outside to CSI drivers, and therefore we need all the features that our internal volume plugins have in CSI first. And it's a long way ahead. Any other question about CSI? What's the time? I still have a lot of time. Great. Yeah, Josh.
So, local volume with stateful set, is that waiting for CSI to be mainstream?
Not really. Local volume is not dependent on CSI yet.
Okay.
What you need is to have the hex we have in scheduler enabled, and that's it.
Okay.
So what did I not cover? Local storage I talked about. You can play with that now. Snapshots. Our users want snapshots. Problem is they don't know why do they need snapshots. Every time on our storage SIG meetings or face-to-face meetings, they say we want snapshots. But if we want use cases, how they are going to use these snapshots and why and how the API should look like based on these use cases, they say, we don't know, we just want snapshots. So, what we did, we collected some use cases and we developed snapshots externally. Kubernetes allows you to run external components, and also they can have API that is stored in the API server. It looks like Kubernetes API, but it's not Kubernetes API. And Kubernetes doesn't care about it. That means you can enhance the API server with your API, and we use that for snapshots. So we introduced new snapshots objects for that. We implemented external code controller. We implemented it for Amazon, GC, Cinder cluster, and maybe already Ceph, I don't know. It can take a snapshot, and it can restore snapshot to a PV. That's all it can do, nothing else. Some people wanted to take snapshot of stateful set, for example. That would take stateful set, all its pods, and take snapshots of all the volumes that these pods run. We will see, maybe, in distant future. It's like proof of concept. I wouldn't run in production. And in 1.10, we resumed our discussions about internal API for snapshots. So maybe this will move to internal, to Kubernetes, and it will be available to everybody. Right now, you have to deploy the snapshot controller and manage it by yourself, basically. For user, it's not that difficult to create a snapshot. You create an object whose kind is volume snapshot external kas.io/v1. That's the API we edit via custom reserved definition. And you say a name of the snapshot object, and you say, what do you want to snapshot? You want to snapshot the claim. And it takes a snapshot. That's all. You can get the volume snapshot object, and you will see the status, how the snapshot is in progress. And if you want to restore the snapshot, you have to run external provisioner that will restore a snapshot for you, and you create a claim. This claim has, of course, special storage class that leads to this special snapshot provisioner. And what's more important, it has annotation telling which snapshot do you want to restore, and that's it. You submit this claim, something happens in the snapshot controller somewhere in Kubernetes, and you get your claim bound to PV that is restored snapshot. That's all. I have a demo recorded because I can't run snapshots on my machine. I have a claim, and I create a volume snapshot object. Everything is already deployed, like these external controllers and APIs. It's already deployed. So I create the snapshot, and now magic happens. If I look at the YAML of the snapshot, it has the spec, the same spec I submitted. It also refers to the snapshot data name I will cover later, but in the status, you can see the progress. The snapshot is usually instant. You take a snapshot of something quickly, but in the cloud environments like GC or Amazon, then there is another process that takes the snapshot and uploads it somewhere so you can restore it. So the snapshot is taken, but it's being uploaded somewhere in the cloud. Nobody knows where it is. And it becomes ready after a while. And this volume snapshot object, it lives in user namespace, and users can create and delete it. But the actual pointer to the snapshot is volume snapshot data that lives outside of user namespace, because it contains sensitive information like. Do I have YAML? Yeah, I have YAML. It contains name of a snapshot in GCE. So if users were able to modify these objects, they could steal snapshots of somebody else. That's not what we want to allow. That's why this snapshot data lives outside of users' control. Only admin can access that. And it's the same like claim and volume. Like claim lives in user namespace. It's user's reference to a volume somewhere. But the real data is in volume that lives outside of user's control. It's the same with snapshot and snapshot data. And that's snapshots. We edit mount options. Well, very simple, very stupid feature. In a PV, you can say how this volume should be mounted. For example, this will be mounted with -o discard. Nothing fancy about it, but users wanted it, and we have been avoiding it for a long time, actually. In alpha 1.7, it's annotation. In beta, we have a special field for that. And you can put also the mount options into storage class. That means if you provision a volume from this class, then it will be mounted with this -o discard. Very simple. We edit mount propagation. If you don't know what mount propagation is, then be happy. You don't need it if you don't know what it is. But if you develop a CSI driver or even a Flex driver, you need to mount things inside the container, and you need these mounts to be seen outside of the container. That's what mount propagation does. It does also other things, and it's a very dangerous thing to play with. But if you want to develop flex volume inside the container or CSI driver inside container, you need a way how to mount things inside the container. So we added new API to Kubernetes. If you run a pod, in the pod definition, you can say how the volume should be mounted. And this volume will be mounted with bidirectional mount propagation. That means R shared in Linux terminology. And that means whatever this container mounts into /mnt host, it will be visible on the host in varlib kubelet. So if this was a CSI driver, it could mount the volume here, and it will be visible to Kubernetes. This works only in privileged mode. The container has to be privileged because unprivileged containers can't mount. So, and the last really big feature is block volumes. You can consume whole block devices and give them to containers, so it's not mounted, it's a block device. And the container can do anything it wants to them. For example, MySQL could use it as a raw database without the file system in between, so it's faster. We don't have dynamic provisioning. It's limited to iSCSI and Fiber Channel right now in 1.10. In future, we want local storage. Local storage to be able to be consumed as block volume because that's where the speed is. And also, we will convert order volume plugins. API is very simple. In a PV, there is new field that says volume mode. What kind of volume it is? It is file system or block. File system is implicit, so you don't need to specify it. All your PVs will work as they work now. Nothing special about that. In PVC, user can ask for block volume, and it will be bound only to PVs with block volume mode and that. Yeah, and in a pod, you say how the pod wants to consume the device, and for example, this volume will be inside the container. It will emerge as /dev/MySQL. It can be anything on the host. It can be SDA, XVDA, whatever. But inside the container, it's dev MySQL. Nothing fancy, but it required a lot of changes everywhere in our volume code. And last but not least is resize. You can resize volume.
This block volume, is it possible to use it for EBS, the Amazon EBS?
Right now, not, but 1.10, yes. In 1.10 release, yes. Yeah.
And is it topology aware already? Or?
It will be topology aware.
It will be.
Yeah. Topology is property of the PV, and it's orthogonal to the block storage. All these features we usually develop with one plugin, for example, block storage with iSCSI and Fiber Channel, and topology with local storage, but it will spread across everything, and in the end, when we declare it stable, it should be everywhere, like block Amazon or topology aware iSCSI or anything. But to keep the testing metrics small, we just focus on the one plugin first. Resize, it's there. It's very useful. People have been asking for that. But from the user experience point of view, it's just stupid. You have a claim. Again, recorded because I don't have resizable volume here. You have a claim. This magic patch changes size of the claim from 1 gigabyte here to 10 gigabyte here. And from the user perspective, that's all. right now during beta, you can see if you list the PVC again, it's still 1 GB PVC because in beta it's not shown in describe of PVC, but if you get YAML of the PVC, you can see new condition here, resizing. That means that the volume has been resized on the storage side, but it needs to be resized also on the file system side. That means currently you need to restart the pod. I hope we will fix it and you won't need to restart the pod, but I have a pod, some busybox, I delete it. Deployment controller creates a new pod after a while, and only after, during starting of the pod, we resize the file system. Right now, during beta. We are going to fix it, hopefully. Surprisingly, such stupid things is not easy to fix. But we will see. So now, after restart, it has 10 gigabytes. So from the user perspective, you just edit the PVC, you change the size, and everything happens. So, and that's probably, if I'm not mistaken, end of my talk. Where's the big? So, that's 1 year in Kubernetes. Any questions? Yeah?
I have read about the VMware storage driver. Do you have any opinion about it?
Do I have any opinion about the VMware storage driver? It's there. It's internal. I haven't used it, to be frank. We have it in Kubernetes. We have it in OpenShift. We support it. But I don't know anything about that. VMware, we have people from VMware are pretty active maintaining it. They're writing tests, writing new features. I like that approach. I wish all the other storage vendors were that active. Because sometimes they provide a driver for us or volume plugin for us, and they don't test it. We have to maintain it. They go out of the business, they bankrupt, and we have to maintain it. So VMware is a good example. Microsoft is a good example, actually. They maintain Azure, and it's not that bad. Any other question? Yeah?
Are Snapshots supporting local storage?
No. No, question was if Snapshots support local storage. Answer is no, but you can write your plugin into our external snapshot controller and implement it by yourself, but that means you must do some LVM or something that's snapshotable on the local storage. Any other question? If not, I have still a couple of minutes, so I will talk about the future. You have seen a lot of these features are in alpha or in beta, and only some things are supported. The user experience is not that great. So in future, in 1.10, we will continue with CSI, and I'm not sure we have any big feature in our queue. And we are polishing all the other features. For example, the block storage will be should be available everywhere. Mount propagation should go to beta from alpha. Mount option should be stable already. Local storage will be alpha for a long time because of the scheduler changes we need. Yeah. Flex volume is stable. Resize needs a lot of work. But the next big thing is CSI. So be prepared for harder deployments of Kubernetes. It won't be just Kubernetes. You will deploy a lot of other things on top of it, and then it starts to be useful. If there are no other questions, then thanks for your attention.
That was good.
Thanks. So.